Continuing in 11.4, we're up to example number 5. Approximate the value of this integral with an error no greater than 5 times 10 to the negative 4. Okay, so we know e to the x. E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus out to x to the n over n factorial and on. And it converges from negative infinity to infinity. So first thing I'm going to do is I'm going to replace the x with the negative x squared, which would turn this into 1 minus x squared plus x to the 4th over 2 factorial. Then it's cubed, so it's minus x to the 6 over 3 factorial plus all the way out to, it's alternating in sign, and x to the 2n over n factorial. And that also converges from negative infinity to infinity. So now we want to integrate this term by term. And so I'm going to integrate that series up there. I'm just going to go like this to keep from having to write it again. So that'd be x, and then it would be minus x cubed over 3, and then it would be plus x to the 5th over 5 times 2 factorial minus x to the 7th over 7 times 3 factorial, all the way out to, let's see, it's going to be x to the 2n plus 1, because I raise the power, and I flip it in front, and then there's an n factorial, and this whole mess is being evaluated from 0 to 1. So, plugging in 1, I'm going to get 1 minus 1/3 plus 1 over 5 times 2 factorial minus 1 over 7 times 3 factorial plus plus negative 1 to the n, 1 to the 2n plus 1 is just 1, over 2n plus 1 times n factorial. And then when you stick in 0, minus, these are all going to be zeros. So that's all I have left. Now, because it's an alternating series, the remainder is going to be less than the first neglected term. So the first neglected term, we're going to the remainder here, is going to be less than negative 1 to the n plus 1, because that will be the next term. And then we have 2 n plus 1 plus 1, and then n plus 1 factorial, which reduces to negative 1 to the n plus 1 over 2n plus 3 times n, plus 1, there we go, factorial. And now, by trial and error, we could have an error of less than, the question is, when is this less than 5 times 10 to the negative 4, which would be 0.0005. So we start plugging in n is 1, n is 2, n is 3, n is 4. When you get to n is 5, you get 1 over 13 times 6 factorial, which is 1.07 times 10 to the negative 4. So the sum of the series of the terms up to 5 gives the approximation. So this answer would end up being 1 minus 1/3 plus 1 over 5 times 2 factorial minus 1 over 7 times 3 factorial plus 1 over 9 times 4 factorial minus 1 over 11 times 5 factorial. And that's approximately 0.747 if you put it all in your calculator. All right, let's take a look at number 6. And this has 2 parts. I may only be able to fit part A on here. Let's see. Use the Maclaurin series for arctan to evaluate that summation. Okay, so we're trying to get to this. Over 2k plus 1. And they also told us this is 1 minus a third plus a fifth minus dot dot dot. Well, arctan is x minus x cubed over 3 plus x to the 5th over 5 minus dot 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 out to negative 1 to the k, x to the 2k plus 1 over 2k plus 1. Oh, it almost looks exactly the same. Negative 1 to the k, 2 to the k plus 1 over 2k plus 1. All I have to do to make the arctan look like the series they're asking me about is to substitute in x equals 1. So the arctan of 1 would be 1 minus 1 cubed over 3 plus 1 to the 5th over 5 minus dot dot dot. K equals 0 to infinity. Alternating over 2k plus 1 would generate odd terms. So now the question is, when is the arctan equal to 1? Arctan of 1, it's at pi over 4. Tangent of pi over 4 is 1. So the value of the series is pi over 4. That one's done. I'm going to see if I can squeeze part B in here to save some paper. Okay, let f of x equal, oh goodness, e to the x minus 1 over x for all x is not equal to 0, and f of 0 is equal to 1. They probably all ran together, sorry. Use Maclaurin series for f to evaluate f prime at 1. So I'm looking for f prime at 1 and the summation k equals 1 to infinity k over k plus 1 factorial. So we could start with the series for e to the x, which I've got written at the top of the page, and just adjust it to get the function in question. So f of x, meaning e to the x minus 1 over x, I'm just going to subtract a 1, and I'm going to divide through by an x. So I'm going to have a 1 over x, and then the bracket, and then we're going to have the e to the x series, 2 factorial plus x cubed over 3 factorial plus dot dot dot, then subtract the 1, close the bracket. Okay, the 1 and the negative 1 are going to cancel inside those brackets, and then when you put the 1 over x through the problem, you end up with 1 plus x over 2 factorial plus x squared over 3 factorial all the way out, and the summation would become, need an equal sign there, k equals 1 to infinity, and this is going to be x to the k minus 1 over k factorial. And that converges from negative infinity to infinity because e to the x converges. And so now they want us to find the derivative. So f prime of x, according to the quotient rule, would be the bottom. I think I finished that one part, didn't I? Now I got to plug 1 into it. Okay. The bottom, so x times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. right? And now I've got the derivative. Let's take the derivative of the function. Where did I write that? Over there. This one up here, the derivative of this series right here is going to be, derivative of 1 is 0, derivative of x is 1, so 1 over 2 factorial plus 2x over 3 factorial plus 3x squared over 4 factorial. And this guy's derivative would be what did I write there? Okay. So I'm going to stick in k equals 1 to infinity, and what's happening here? The bottom is k plus 1 factorial. The top is k times x to the k minus 1. Now we have two different expressions for f prime, and if we evaluate them both at 1, the derivative at 1 is going to be 1 if I plug it into the f prime over here on the left-hand corner. F prime at 1 from up here is going to be equal to 1, and from over here it's going to be equal to the summation k equals 1 to infinity of k over k plus 1 factorial. So I have found, it asked me to evaluate f prime of 1 and the summation. Now they're both equal to 1. So that one's done.